Station logic in RobotStudio allows you to add various physics behaviours and other logic components to the simulation, which can in turn simulate real-life behaviours. For example, you can add collision sensors that activate when a collision is triggered, or even attach an object to another model. You can also use the IOs that we have added to trigger other behaviours like closing and opening the gripper. To open up the station logic window, navigate to Simulation, then Station Logic. From here, you can see all of the components that are currently in the simulation, including the box and platform. Clicking on Add Component brings up groups of various components, including sensors, actions, manipulators, etc. These are called smart components, and this is where we can start to add our various behaviours to the simulation. Going back to the simulation, we know that we want the gripper to open when the arm is over the box, like so. By navigating to the gripper, and then going to Mechanism Tools, we can actually add the current open position of the gripper to the simulation. This is done by clicking on Move to Pose, then clicking on Edit Poses. From here, you can see all of the available poses of the gripper. Home position and sync position currently both have joint values of 0 mm. This is when the gripper is fully closed. Click on Add Current Pose. There is now a new pose called Position 1 with a joint value of 25 mm. From the current pose, we know that this is when the gripper is fully opened. We will call this pose Open Grip. The transition time is how long the gripper will take to go from a given pose to the current pose. We will program this separately, so leave this for now. Press OK to confirm the change. We can test the poses by clicking on Move to Pose, then alternating between Home Position and Open Grip. As you can see, the gripper now opens and closes. We now need to link the signals that we have made earlier with this behaviour. To do this, go back to Station Logic, go to Add Components, down to Manipulators, then to Pose Mover. As you can see from the description, Pose Mover moves the mechanism to any poses that we have set. In our case, this is the pose we just added to open the gripper, along with the default closed pose. Click on the Design tab. From here, you can see the pose mover that we've just added. We can also see a component related to our IRB arm. This is the virtual controller, and from here, you can bring up all of the input and output signals in the controller, including the ones that we've added separately. Click on the small drop-down arrow and simply click the other signals. We now need to define the pose mover that we have added. Click on the pose mover. Navigate to Properties next to Paths and Targets. Clicking on Mechanism allows you to select the gripper. This pose mover is responsible for opening the gripper, i.e. moving to the open grip pose. So, set the pose as open grip. Now we can specify the time taken for the gripper to open. We will set this transition time as 1 second. Clicking on Apply confirms these changes. When we set open grip to 1, we want the gripper to open. So, the open grip signal must be linked to the pose mover. To do this, you can actually graphically link the two together by simply dragging from open grip to the execute in the pose mover. This will add a link from open grip to execute. Execute has two possible values. When execute is set to 1, the pose mover will start the movement. So, when our open grip is set to 1, this will in turn set execute to 1, opening the gripper. Once the gripper has fully completed the pose movement, it will set executed to 1. This signifies the end of the movement. You can link this executed signal to our grip opened input signal. We can test this part of the simulation to see if what we programmed works. Before we do this, we need to add a way of starting the simulation from one button, rather than having to enable and disable our signals manually. We already have a start sim input signal in the controller, so we can now link this to a new station input signal. To do this, simply click on the plus icon in Inputs. We will be using a digital input, so the default choice is fine. Click on Auto Reset. This allows you to immediately reset the state of the signal. We will call this Start Sim. Press OK. We now have an input to the left that we can wire to our Start Sim input signal in the controller. Now we can test this. Go back to our view and click on I/O Simulator. Now, in the Controller tab, click on Station Signals. As you can see, the Start Sim station input we added is here. Press play. Nothing is currently happening since we've not pressed Start Sim, so go ahead and do this now. The arm moves to our home position and down to over the box and opens the gripper. After opening the gripper, it then moves to the box position. This is exactly as we programmed. We now need to add another pose mover component to close our gripper. Navigate back to Station Logic. You can also directly add smart components in this graphical window by simply right-clicking anywhere. For efficiency, there is a tab that shows you what components you've used recently, right here. Click on Pose Mover. Now, navigate to Properties and repeat the procedure we used for opening the gripper, but now changing the pose to Home Pose, which will close the gripper. Again, use the same transition time of 1 second. Now, wire our close grip signal to execute. So, when close grip is set to 1, this pose mover will close the gripper until it is fully closed. However, going back to the view, we can see that at this position, the fingers of the gripper will collide with the box. So, a fully closed gripper will simply go through the box. To fix this, we now need to add a sensor that will detect the gripper colliding with the box, and then attach the box to the gripper once the collision is detected. We will use a collision sensor and attach a smart component to do this. Go back to Station Logic and bring up the sensors. Now, click on Collision Sensor. Bring up the components again, go to Actions and click on Attacher. As you can see, our window is starting to get clogged up with components, so use the scroll wheel on your mouse to zoom in and out of the window, or alternatively, use the slider at the bottom to do so. Click on Collision Sensor and navigate to Properties. Object 1 and Object 2 refers to the two objects that will be monitored for a collision. Click on our gripper and the box for these two objects. We want the gripper to exactly collide with the box without any near misses, since that is what happens in real life when a gripper picks up an object. So, leave the near miss value as 0. As you can see, this is set to active throughout the whole simulation. So, whenever the collision is detected, sensor out will be set to 1. When this happens, we want to stop the gripper from closing further. So you can wire the sensor out signal to cancel. This cancels the whole movement and resets all the signals in pose mover components back to 0, leaving the gripper in the same position. Click on Attacher. The parent is the object that attaches, and the child is the object that is being attached. So, in our case, the parent is the gripper and the child is the box. You can simply wire the objects from the collision sensor component to the relevant parent or child like so. we want to attach the gripper to the box after the collision is detected. So, wire the sensor out signal to the execute signal. Once the box is attached, we want to let the controller know that the box is ready to be moved to the platform, and we know that our grip closed signal needs to be set to 1 to do this. So, simply wire this executed signal to grip closed. We have one final component to add to our station logic. When we reach the platform, we need the gripper to let go of the box and then open the gripper back to normal. To let go of the box, we will use a detach a smart component, and this is again found by bringing up our smart components, navigating to actions, then clicking on detacher. The child is the object being detached, which in our case is the box. So simply wire the child from the attacher to the detacher. Our open grip signal in the controller will open the gripper at the platform. So wire the signal to execute in detacher. Once the box is detached, the gripper can open. So now wire executed to execute in our open grip pose mover. We have now added all of the necessary smart components and have also programmed all of the logic needed for our pick and place simulation. Let's test this out now. Press play and click on Start Sim to start the simulation. As you can see, the arm now picks up the box and places it on the platform and moves back to the home position. Using the same logic in the pick and place to platform path, we can add another path that will pick up the box from the platform and place it back in the original position. To save time, we can directly copy the path we have created and change around the order in which the arm moves. Right-click on the path to copy it, then paste. Rename this path to Pick and Place from Platform. Now we just need to change the order of the move instructions. So let's go through this step by step. From the home position, we want to go to hover over the platform. So drag hover over platform to underneath home. From here, we want to open the gripper. So delete the hover over box instruction. After the gripper is opened, we want to move the gripper to the box, but we know that this is now the platform position. So drag this instruction to after open grip is set to 0. We then want to close the gripper and pick up the object, so delete the box position instruction. Once the gripper is closed and it picks up the object, we want to move back up to over the platform, then go over to the box. So just swap these two instructions around. We then want to move to the actual box position before releasing the box. So drag the box position target to the path. Once the gripper releases the box, we want to move back up to over the box, then go back to the home position. So copy the hover over box instruction and paste it after open grip is set to 0. Again, click No. The new path is now complete, and we can now test this. Synchronize all of the changes we've made to the controller. Now press play and press Start Sim. And now, by changing the entry point each time to the simulation, we can alternatively pick and place the box to and from the platform. This concludes the pick and place tutorials.